Hi, my name is Fu, and we're here at DesignCon doing a demo of our new PCI Express Jammer product. So what the Jammer is, the basic setup, as you can see on the screen, is an inline error injection tool. So it sits transparently between a root complex or motherboard and also an endpoint device. The Jammer, when it's not programmed for error injection, will sit transparently and it will not affect the application that is running. But what we could do is program the Jammer using a PC and start injecting different types of errors. As one of the things our customers will be most concerned about is, does their application and does their device have the right types of error recovery mechanisms when these different types of errors occur. So what we have for this demo is a fairly simple setup, a system that has the Jammer included. We have an application running. In this particular case, it's a video application showing a video stream. And what we have on this side is a PC that is controlling the behavior of the Jammer, and we can control that behavior to inject different types of errors. Okay, so the Jammer is running and the video application is running right now. What you can see is the video is playing very smoothly. There's no degradation that's introduced by the Jammer. Okay. So the next thing we're going to do is we are going to control the Jammer and start injecting some errors. The Jammer can inject errors at all levels, so physical layer, data link layer, as well as the transaction layer. What we are going to do right now is do some error injection in the data link, in the physical layer. What we're going to do is just randomly, and we can program the random interval, inject disparity errors, and we have full control over where the disparity errors will occur, whether it's any of the bytes in the header is possible. In this particular case, we have selected bytes 6 and 7 of the header. And once I start running the sequencer, what the Jammer will do is to start injecting these errors. So I'm going to hit the play button to start the Jammer sequencer. Okay. So the effect you see is, because we're now injecting errors into the system, the graphics card is recovering from those errors. So physical layer errors that we're injecting is recoverable by the hardware. But what you will see is once we do a degradation in the physical layer, we actually see that the performance of the video or the performance of the application degrade. What our customers are concerned about is mainly, one, what kind of performance degradation do we see? And then the second item is, does the device recover correctly? In this case, the graphics card is able to recover from these errors. A graphics card that's not designed well or does not have the right error recovery mechanisms will potentially see the application crash, and that's the kind of tests that people want to do with an inline error recovery or error injection tool such as the Jammer product from Agilent. So, in order to validate the correct error response, typically what you would use is an analyzer in conjunction with the Jammer. So the analyzer and the Jammer really work hand in hand in making sure that your device has the right error recovery mechanism. And in order to help that, the analyzer can be directly connected to the Jammer through a mid-bus footprint. And there's also triggering mechanisms from the analyzer to the Jammer, or from the Jammer to the analyzer, in order to capture the right error recovery mechanisms in the system.